To finish off this set of movies, we'll talk about something that will very definitely be expected of you for A-level, and that are further isotope effects. We've seen, of course, isotopes all the way from the start in our discussion about mass spec. Very significant discoveries of isotopes using mass spec or early versions of mass spec. We saw how the fact that you have carbon-13 is 1% of carbon atoms can give you those extra little M+1 peaks, or peak plus 1 peaks in some of the carbon-13 NMR. Well, we're going to finish off with a couple of other isotope effects that you will encounter when you're talking about halogenoalkanes. And we'll start off with chlorine. As I trust you know by now, chlorine has two significant stable isotopes, chlorine-35 and chlorine-37, that occur in a ratio of 3:1. So what we should expect to see in mass spectra of chloroalkanes is we should expect to see two peaks separated by two mass units, one of which, the lighter peak, is 3 times bigger than the heavier peak. So if we illustrate this, for example, with chloropropane, okay, chloropropane, the big base peak is at 43, and that's the C3H7, so just essentially losing a Cl. Okay, but we're not interested in that. What we're interested in are these two peaks here that are separated by masses of 2, right? So 63 to 65 and 78 to 80. And I hope you can see that the heavier peak is about 1/3 of the height of the lighter peak. So if we think first of all about the ones at 78 and 80, okay, these are the molecular ions. C3H7 is 43 plus 35 chlorine, so that's chlorine atom weighs 35, or 43 plus 35 is 78. And so 3/4 of the molecular ions will weigh 78. But then you'll also have molecular ions that don't contain 35 chlorine, they contain 37 chlorine, so that's 43 plus 37 is 80. So these are the molecular ions, but you see two molecular ions of that ratio 3:1 because of the two different isotopes of chlorine. Now, if we take 15, and of course 15 is a CH3 group, away from 78, we get 63. And if we take 15 away from 80, we get 65. And so we see this pair down here, 63 and 65, that are those same molecular peaks, but having lost CH3. So take CH3 away from C3H7, you get C2H4. So that's 24 plus 4 is 28, plus 35 is 63. So that's one of those peaks, losing CH3 from the 35 chlorine version, and then 2 higher, losing 15, losing CH3 from the 80, gives us C2H4, 37 Cl. Okay, so very distinct isotope effect associated with chlorine. Two peaks, two mass units apart, where the lighter one is about 3 times bigger than the heavier one. Same idea with bromine. Bromine has two nice stable isotopes, 79, 81. These are in a 1:1 ratio. So we should expect to see two peaks of about equal height, two mass units apart. So instead of looking at chloropropane, let's look at bromopropane. There is the spectrum of it. Again, that's the dominant C3H7 plus because you've lost that halogen radical. Very easy to lose Cl dot and Br dot, leaving you behind with these. But now look up here. You can see two peaks, two apart of the same height. That's another two peaks, two apart of the same height there. Two peaks, and so on. But these are the big ones, okay? These are the molecular ions at 122 and at 124. 122 is C3H7, that's 43, plus bromine 79. 43 plus 79 is 122. And then 2 higher, 124, 43 plus 81. Equal heights, 2 apart. Now, of course, if I wanted to really squint, 122 minus 15 is 107. That's the 107 peak from losing methyl. 124 minus 15 is 109. There's the 109 peaks. You can see those two teensy little blips there, equivalent from losing the CH3, but the much nicer ones to look at there are the molecular ions, one for bromine 79, one for bromine 81. Hope you enjoyed the Maths Spec discussion.